Hi everyone, hope you are learning and then you are taking the lessons very seriously. You are going through them, making notes, and probably doing your best to be able to understand them. My name is Nana Yawedu, and you can call me Say Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all the videos on time. In our previous lesson, we have looked at how we can find the zeros of a function. We mentioned that for the zeros of a function, it's the values of x in the function that makes the function 0. So any value of x that when we insert into the function will make the function 0 is a 0 of the function. In this lesson, we want to look at a series of functions, some types of functions that will be very important for us to be able to look at the inverse of a function. And one of those series of functions will be the injective function. So we want to look at when a function is called injective. What does it mean when a function is called injective? How can we apply it to real life examples? And then we'll move on in other subsequent lessons to look at surjective functions, and we'll consider bijective functions. So let's consider these functions. So when we look at these, we see two different types of functions. So the first one, we have A mapping to B, where 1 maps to 5, 2 maps to 8, and 3 maps to 6, right? So we can use an example of probably saying that the 1, right, the 2, and the 3 could constitute some countries, which could include Ghana. We can have Togo, and then we can also have Cote d'Ivoire. And then its corresponding 5, right, 6, and 8 are the capitals of these countries. So 5 will be Accra, and then the 6 will be Abidjan, and then the 8 would be Lome, right? And let's consider that our 7 is Ouagadougou, right? Ouagadougou, right? So we say that for injective functions, they are functions that the members of the domain are mapped to a unique, right, codomain, or are mapped to a unique image in the codomain, right? So the injective functions are functions where every member of the domain are mapped to a unique member in the codomain. So for injective functions, you realize that there is no member in the domain that is not mapped to any member in the codomain, right? But then there could be a member in the codomain that does not constitute the range. So for instance, this game where you could create a game of countries and their capitals, and in this case we have 3 countries, Ghana, Togo, and Cote d'Ivoire, right? And then their capitals, which represents Accra, Abidjan, and Lome, where we could map, right, Ghana with Accra, Togo with Lome, and Cote d'Ivoire with Abidjan. We can have one of the capitals, right, like Ouagadougou, which is the capital of a country that does not include, right, that does not have its corresponding domain. But then we could say this is what? An injective function. So for instance, if you have 1 mapping to D, 2 mapping to B, 3 mapping to C, and 4 mapping to A, we can say that this function is an injective function. So another name for injective function is a one-to-one function, right? Another name for injective function is a one-to-one function. So let's look at the definition for injective function. So we say that an injective function is a type of function where every value that is in a domain, right, every value that is in a domain, there is a unique output that it maps to. So for every value in the domain, there is a unique output that it maps to. And we call an injective function a one-to-one function, right? So another name for an injective function is a one-to-one function. So mathematically, we say a function is injective if all elements x and y in the domain A, the f of x is equal to f of y, and that implies that x is equal to y, right? So for instance, if we have a function y to be equal to 3x minus 3, right, we could say that f of x is equal to f of y, right? That implies that our f of x is equal to 3x minus 3, the normal one that we know. And then f of y will be equal to 3y minus 3. And we can equate these two functions, right? Since we say f of x equal to f of y, 3x minus 3 is equal to 3y minus 3. And by algebra, when we move the minus 3 across the equal sign, we are going to have 3x to be equal to 3y. And that implies that x is equal to y. So we see that a function like this is injective because s becomes equal to y when we equate them, right? So mathematically, this holds. F of x equal to f of y implies s equal to y holds for all functions that are injective. If it is not injective, then it means that this will not hold. So let's consider this example. It says that determine whether or not the function g of x, which is equal to 2x minus 3, is injective, right? So the function g of x is equal to 2x minus 3. We want to determine whether or not the function is injective. So we say that for injective functions, right? We say that for injective functions, we need to quote what it means. For injective functions, right, f of x is equal to f of y implies that x is equal to y, right? So we write out the function given is g of x, right? So we could write this as what? G of x is equal to g of y implies that, right, x is equal to y, right? So that we can have our g of x, which is equal to 2x minus 3, right? So it means that our g of y, we are going to substitute, right, y in place of x. So that becomes 2y minus 3. And then since we say g of x is equal to g of y, we will have 2x minus 3 to be equal to 2y minus 3. Right, so that implies that we will have 2x to be equal to 2y minus 3 plus 3. We move the negative 3 across the equal sign. And that implies that we get our 2x to be equal to 2y. And we can divide both sides by 2, right? So that we can have our x to be equal to y. So in this case, we can conclude that since s is equal to y, then we can say that the function g of x is injective, right? So that is how we are able to determine whether a function is injective. So based on this example, let's try and see if we can determine whether another function is injective. So let's take this function. You pause the video and try and solve it and write it in the comment section, right? So is the function f of x, which is equal to s squared plus x minus 1, injective, right? So go through the same process and try and determine whether the function f of x, which is equal to s squared plus x minus 1, is injective by having f of x to be equal to f of y, substituting f of y in place of x, and equating them to see whether s becomes equal to y. And then put the response in the comment section. So basically in this lesson, we have looked at injective functions. We have considered injective functions as functions where the domain maps to a unique element within the codomain, right? So in our next lesson, we want to consider surjective functions. We want to look at what the surjective functions mean and how that also applies to real life. Remember to like this video, share this video, and subscribe to my YouTube channel. See you soon.